All right, hi everyone, and welcome back. This topic video, is the electrochemical cell. Okay, so on your test coming up this week and on your final exam, you're going to be required to calculate the cell potential of a particular electrochemical cell, and you're also going to have to label the parts. Now, typically would have you draw or sketch an electrochemical cell. It's a little bit different this term because where everything is multiple choice on our exam. So rather than have you draw, you're going to get a blank diagram and you have to pick out the parts, which is the anode, the cathode, the salt bridge, electron flow, ion flow, etc., etc. You're going to be given your information about your electrochemical cell probably like this here. So given two half reactions, both of which are written as a reduction reaction, because right now both of these are written like they are gaining electrons. And as you know, in an electrochemical cell, you have one reduction and one oxidation. So one of these two reactions is written the wrong way. One of them has to flip around and become our oxidation. You need to decide which one that is. How do you do that? So you're going to look on your table of standard reduction potentials. I have the table right here. This is the one from your data booklet. So you make sure you grab this table for your quiz coming up this week. You're going to want this. Sorry that it's a bit hard to see like through the camera. But have that table with you when you're doing all of your questions for electrochemistry, okay? So you're going to look up and find those two reactions. The reaction that is further to the top, so closer to the top of the list, is the one that stays as a reduction. The one that is below flips around and becomes our oxidation. So if I look on my table, I find my copper 2+ reaction, and I find the zinc reaction, and copper is above zinc. So copper is going to stay as the reduction reaction, and that means that zinc is going to turn around. I got to switch that one around. That's going to become my oxidation. So I'm going to go ahead and I'm going to write zinc the opposite way. Okay. So then I know that that is now my oxidation. At this point, if you wanted to, you could write down the voltage of both of them and do your cell potential right now. So that copper reaction is positive, let's see, positive 0.34. And the zinc, currently the zinc is a negative 0.76 on my table, but don't forget I had to reverse that zinc reaction, so this is actually a positive 0.76 volts. And if you wanted to at this point, you could write them, you could add them together to get your total cell potential. So this comes out to be positive 1.10 volts. Now, you want to make sure that you do actually get a positive voltage for this particular question, right? Electrochemical cells are spontaneous. It means they happen all on their own. They have a positive cell voltage, okay, which is different than an electrolytic. An electrolytic is non-spontaneous, and you're going to get a negative cell potential for that one. So make sure you're getting a positive voltage when you calculate your cell voltage for the electrochemical cell. All right, so what's the next part of this question is to be able to sketch or draw. Even if you wanted to, you could try to draw. We'll just do a quick sketch. You're going to get a blank diagram, okay, on your quiz and on your final, and it's going to look a little something, you know, like this. Now, I'm not the best artist, of course, as you all know, but it's not an overly difficult picture to try and draw. So 2 beakers. I've got a solution, you know, inside each one. I've got a metal electrode on each side, and then I've got this curved sort of bridge connecting the 2 pieces. All right, so what are you required to show on your diagram of your electrochemical cell? Anode, cathode, salt bridge, direction of electron flow, which one is your positive and your negative terminal, and then the direction of ion flow, also very important. Now, I think maybe it's just convention. I'm not sure actually if it is or not. but the anode is always on the left. So when you draw your picture or when you label your picture of your cell, your anode is on the left and your cathode is on the right. Okay? Your anode is your negative terminal, of course, in an electrochemical cell, and your cathode is your positive terminal. So if you want to write that in right away, you can. Your anode is your oxidation side. So going back to the two reactions that we started with, which one is your oxidation? Well, that's your zinc. So this piece of metal that's here, this is actually, right, a piece of zinc. And then your cathode is your reduction side. So that piece of metal is a piece of copper. Okay? Your two pieces of metal are connected through a wire. And then, of course, you'd have you know, a voltmeter or something so that you could measure your potential. In your electrochemical cell, your anode is the one that gets consumed in the reaction. So zinc is losing electrons, right? Just like my reaction showed, zinc is losing electrons. And they're going to flow from your anode to the cathode. Because electrons are negative charge and your anode is negative, right? They get repelled from your anode side. They're attracted towards your positive cathode side. So your electron flow is always from anode to cathode. Very good, easy peasy, right? Now, inside your cell, you've got this bridge connecting the two pieces. This is your salt bridge. This is necessary so that you've got this electrical neutrality maintained in your cell. You have to have some means for the ions to flow to create this circuit that's going to create your cell potential, right? So you've got to have some way for the ions to get from one side to the other. That's through your salt bridge. In your solution down here, this is the copper. This is probably like, I don't know, copper nitrate maybe. Could be copper sulfate. Whatever it is, it's got a negative ion. But it's not necessarily important what that particular negative ion is, but there's something there in order to get copper into that solution. So it's, you know, maybe a nitrate or a sulfate. And then on the other side, because your zinc has been losing those electrons, it's formed zinc 2 positive. Now, I mean, you got copper 2 positive down here as well. These are positive ions on that side. And of course, there's also negative ions on this side, because you wanted to get your zinc solution there somehow as well. So there's a bunch of ions flowing around here in these different beakers. Now, as your electrons are going from your anode to your cathode, they are building up a negative charge on your cathode side. And it forces the negative ions that are in this solution the other direction. They're repelled from this buildup of negative charge, and your negative ions are going to travel through your salt bridge, okay, towards your now less negative anode side. It's still negative, it's still the negative terminal, but because the electrons are building up charge on your cathode, your anode is actually slightly less negative. So your negative ions are attracted towards your anode. They go from cathode to anode. When it does that, it forces the positive ions that are in solution. So I'm going to make this a little bit bigger so we can see it because it gets a bit messy. It forces the positive ions that are in the solution the other direction. Okay, also through the salt bridge, but again, it's a bit messy, so I'm going to draw my arrow just slightly below. Through the salt bridge towards my now cathode side, which is building up that negative charge. So those positive ions are attracted to the now slightly more negative cathode side. Even though my cathode is my positive terminal, right? It's building up negative charge, so it's kind of attracting those positive ions to that direction. So there's a lot happening here. There's a lot going on in this cell. But when you're labeling this for your quiz and for your final exam, this is what you're going to want to look for. So what is your anode? Right there. What is your cathode? Other side. Your electron flow always is anode to cathode through the wire. Your negative ion flow is cathode towards the anode through the salt bridge. Your positive ion flow is anode to cathode through the salt bridge. Your anode is your negative terminal initially. Your cathode is your positive, right? But we're building up negative charge here from these electrons. That's what causes your ions to move, one to the cathode side, one to the anode side. So there's a lot happening, there's a lot going on here. Every electrochemical cell will be labeled in a very similar way, right? It just depends on what your actual anode and your cathode is. That comes from your reactions, what your two physical actual metals are. But your direction of electron flow and your direction of ion flow is never going to change. It doesn't matter if this is copper, zinc, magnesium, lead, iron, whatever. Right? We still have the same directional flow in our electrochemical cell. The only thing that's going to change is what your actual physical electrodes are. What are those pieces of metal? Now, there's a couple of questions in your workbook you can try like this. There's a blank cell that you can practice labeling, and I would highly suggest doing that before your quiz coming up this week. And if you have any questions, of course, make sure you reach out and ask. And see you in class this week. Have a great rest of your day, everyone. Bye.